Hello everyone. My name is Akash LM. I'm from final year Computer Science and Engineering branch, studying in NMAM Institute of Technology, Nitte. And here we have Chinmaya. Chinmaya.
Hello, my name is Chinmaya and I'm also from my fourth year engineering in computer science, studying in MIT Nitte. So basically, we are here today to explain what we did in this IoT based home automation project held by Emertxe Information Technology. So let's see what the project was. Our project basically was home automation using Arduino and Blynk application. The interface in between was PicsimLab. The modules which were there in the project were garden lights, fans, and water tank. What the garden lights we did basically was we were turning on the lights or turning off the lights if it was day or night, respectively, and we were controlling the fans and heater if it was too hot or too cold, also sending the notification to the LCD and the Blynk application. In water tank, we were actually controlling the water level based on its capacity, and also here we were sending the notifications to the LCD and the application. Now, before actually jumping into what the project was or how we implemented it, I would like to say what we learned in this internship. In the week one, we were first introduced to C programming. How does C work, or what are its data types? Then later on, actually, we learned about the conditional statements and the different types of operators used in C. Afterwards, the class got even interesting when we dived into pointers and functions, which was really good. And then we slowly went into string manipulation and storage classes in C. In week 2, we were introduced to C++, how the classes can be made in C++, how is the object created, and then we were introduced to constructors and destructors. Then finally, we were introduced to IoT and its application, the heart of this internship. Then slowly were taught how to install Arduino IDE, then null modem emulator, and also PicsimLab, and all the required libraries too. Basically, in the week third and week fourth, we started building our project, which is home automation project, using all these libraries and all the applications required. Now over to you, Akash.
Coming to the home automation IoT based solution, here is the overview of the project. So first one is the purpose of the project. The purpose of this project is to bring up a IoT based home automation solution for controlling home appliances remotely, uh, which in turn makes life more convenient for the users. And coming to scope of the project, it is the home automation is simulated using PicsimLab simulator, and we used a Blynk IoT mobile application to control the home appliances. So in this project, we should be able to control the lights, temperature of the home, and related to water tank, its inflow and outflow, using a Blynk mobile application. And next, coming to assumption and dependencies, what assumptions we did is all the peripherals which we used or which we simulated in this project uh, are are virtual. We didn't use any real-time objects. So coming to dependencies, we we use the Blynk mobile app to control our devices. Yeah. Coming to functional requirements, so this is a schematic diagram which represents our home automation project. So in the first image, you can see there is a home which is like we have all the devices are in our home, and then we have a Pixim simulator, which is or it's a circuit which is connected to all the devices in our home, And then we have a mobile app, and this mobile app is connected to our circuit using a Blynk cloud server. So this is overall a diagram of our project. So next, coming to the functionalities. First functionality was a garden light control. So the description goes like this. So we read the LDR sensor value, and based on the reading from LDR, we vary the brightness of the LED, which is nothing but light, which resembles controlling garden lights based on the availability of the sunlight. You can see the diagram below, which has a Arduino Uno module, and we have lights, and we also have a LDR sensor. So here light is a output device. We can see arrow mark is going towards the light. So light is the output device, and LDR sensor is an input device. So based on the value of what LDR gives, we are controlling the lights of our home. So this is about garden lights, and then coming to temperature control system. So the description goes like this. The temperature control system consists of a heating resistor. It is also called an LM35 temperature sensor, and a cooler, which resembles the temperature control system at home. Now we read the temperature from temperature sensor, that is LM35 temperature sensor, and then we display it on CLCD. So we control the temperature of the system by either turning on or turning off the heater, or by turning on turning off the cooler using a Blynk IoT mobile app. So here is below is the diagram which you can see overall structure of temperature system which we have built in our project. Here you can see a temperature system. We have a Arduino. So Arduino temperature system is being controlled by Arduino. So we have heater and cooler control, which is controlled by Arduino, and temperature in turn gives the temperature as output. So this circuit will reflect all the temperature values and all the notifications into our mobile app, and also we have a CLCD connected, so temperature and notification will be displayed on CLCD also. So this is all overall temperature control system works. And then coming to water tank inlet outlet and valve control. So the description goes like this. So we read the volume of the water in the water tank through serial communication or UART protocol, and we display it on the CLCD, and even we control the volume of the water in tank by controlling the inlet and outlet valve. And we also we control it using a serial communication, and we also display the volume of the water in tank on the CLCD. So we have the same schematic diagram which we used for temperature system, but a small difference is, instead of controlling heater and cooler, we are controlling inlet and outlet valve of a tank. And instead of returning a temperature of the system, we are returning the volume of the water present in the tank. That's it. So this is same as a temperature system. And going to next one, we have user interfaces which will be explained by Chinmaya. So over to you, Chinmaya.
The user interfaces which we used were basically Blynk application. The Blynk cloud is where we were storing all the data using the virtual pin. Basically, what Blynk was made for is entirely for IoT. It can control hardware remotely. It can display sensor data. It can also store data and visualize it and do many other cool things. And some of the widgets which we used on this Blynk application were button widgets, gauge widgets, then terminal widgets. Button widgets were to control the heater, cooler, inlet, outlet valves. Gauge widgets are to display the temperature and the volume of the water in the tank on the mobile application. Terminal widgets are to display the notifications whenever there is a threshold crossed, like temperature is more than 35 degrees, or it could be turning off the heater, or it could be something like water level is full, or also it could be water inflow is disabled. Next, Blynk IoT app here on the left side, we have shown the tab one where the heater control, cooler control, and the gauge widget, which shows the temperature level in the room, is displayed. And on the right side, we have the button widgets, which are used to control the water level in the water tank. The left side one is inlet valve, and here is the outlet valve to turn on or to turn off both of the valves, and also a notification terminal to print the notification. Now the threshold control. When the heater is basically on, we are checking if the temperature is more than 35 degrees Celsius. If it is basically more than 35 degrees Celsius, we are turning off the heater and sending back a message, or sending back the notification as temperature is more than 35 degrees Celsius, turning off the heater. This should be displayed on the virtual terminal heater off on the CLCD. And also in the water tank part, we actually show that the valve, uh, the water level is full if then the inflow is disabled. Notifications which are here as such. On the left hand side, we have the heater notifications on the CLCD, and these are the cooler notifications on the CLCD. Basically, when you turn on or turn off the cooler widget on the Blynk app, it is reflected over here. Same with the heater, and also the water tank notification on the CLCD also shown here. These are the outlet valve notification. One is on, another is off. Same with inlet and on and off. And now the notifications actually on the Blynk, the Blynk application, when there is a temperature more than 35 degrees Celsius, so we are turning off the heater control widget and displaying this on the terminal. And in the water tank part, when the water level is basically less than 2000, we don't let the outflow to happen. We just enable the inflow of water. And also, if it actually becomes equal to 3000 liters, then the water inflow is just disabled. Now, Akash will be explaining the project images and what it is.
Okay, coming to screenshots or project images, what we did. So in the you can see all the setup where we have Arduino IDE here, and we have a Pixim module, and on the right we have spare parts. All are connected through some pins, and then we have a serial tank in between. So this is a home automation software setup. What we did in order to do this project, and this is another image where in which we are displaying a mobile application also. So you can see in the center we have a mobile application which is controlling the whole system. So this is another image of a project. So next going to yeah, as Chinmaya said, we have two tabs, IoT app, where we have all the notifications, all the button widgets and the gauge widgets, and on the right we have a serial tank which is also connected to our device. And this is about the image. And coming to conclusion of our project, so what we did in this project is by using a Blynk IoT application and PicsimLab simulator, we simulated the home automation system where we have LED, temperature system and serial tank, which is resembling light, heater cooler and water tank in real time. And also we have included CLCD, which acts like a dashboard, which is used for displaying the events. And even we have widgets from Blynk IoT app like button widgets, which are also used to control heater, cooler and inlet outlet valve. And then we also included gauge widgets to display the temperature and the volume of the water. And this is all about our project. And thank you for being with us and our demonstration. We still have with a demonstration which will be explained by Chinmaya again. Over to you, Chinmaya.
Thank you. Now let's see how our actually project is working. Let me just load the hex file. This is basically my mobile which is being mirrored to the laptop, and this is the serial remote tank. And here we have the spare parts, and this is the Arduino Uno module. So basically when we connect the serial remote tank, the water tank, you can see that as the water level was very low, basically zero, the inlet automatically has been turned on. You can see that this was not actually on before, but it was automatically turned on, and the volume is slowly being filled. The water is being filled in this water tank. As soon as you can see the water level hits 2000, if we just try to turn it off the inlet valve, it doesn't try to turn itself on or something. If you turn on the outlet valve, if it falls below 2000 liters, it shows here that water level is less than 2000. So you need to have the inflow enabled. And now as and when you can see the water level is full, that is equal to 3000, the water inflow, this valve, is automatically disabled. And you can see the notification here too. Coming to the heater and cooler part, if you actually turn on the heater control over here in the mobile app, you can see the heater is turned on and it is also displayed on the CLCD here. And as soon as the temperature hits more than 35 degrees Celsius, heater is turned off automatically. We have designed it in a such way. If you now turn on the cooler part, slowly you can see even here the and also the CLCD part, the temperature cools down and the heater, it's not heated now. The temperature is cool. And now we can turn off the cooler too. And as you can see, even the garden light implementation here, if you uh, reduce the resistance, you can basically see that the LED over here is turned off, because there's the resistance. We can easily understand that there is you know more light. There's more light intensity there. The light rays are falling on the LED and on the LDR, I'm sorry. And we can see the LED is on now, because it's almost night, because there is high resistance and there's no light on the LDR. We have also added a just buzzer to just you know show that there is enough light, and just an experimental addition we have done. That's all about our project. Thank you so much. Over to you, Akash, now.
Yeah, that's about a project which we have done in this internship. So this is one of the wonderful internship what we have done in our engineering also. And yeah, thank you for giving an opportunity uh, for doing such a wonderful project. So yeah, thank you.